Picking back up where we left off, we're going to start with the implicit derivatives. See how far we can get this time. Um, so with implicits, remember every time you take the derivative of y, you need to attach dy over dx um, as part of it. So you don't have to attach anything to the derivative of x because dx over dx is equal to 1. So we're going to start at the beginning here. The derivative of x to the fifth is 5x to the fourth. You don't need anything after that. And then our next term is 7x. Well, that one's going to be pretty simple. The derivative of that is just going to be 7. But then the next term, that's a product. You have to do the product rule. So make sure that you just, brace yourself. Okay, so you got x to the fourth. Well, the derivative of y is dy over dx. And I know you don't need all these grouping symbols, but I use them to keep my head straight of what I've done and what I haven't done. So I'm using the brackets to say, okay, I'm doing the product rule, and that this is where it is. And I'm letting myself know, okay, this is the first term, and in here is the derivative part. And then I'm going to have my little plus sign, and then I'm going to do it the other way. So I've got my y, and in the parentheses is going to be the derivative part. So I use the grouping symbols to let myself know what I'm doing and when I'm doing it. So you can kind of structure it however you need. 4x to the third, and then I don't need an addendum after that. I need to pick up the problem where it was. Now, quite honestly, I just can't, I marked, I couldn't tell if that was a plus or a minus, but it looks like it's a minus. I need to put my bracket. That's going to be a minus 3y squared dy over dx. And then when I do the derivative of 10, remember any derivative of a constant goes to 0. So that wipes out. Now, right here at the beginning of my product is a plus sign. So I'm really not distributing anything, but it's a good habit to bracket that off or anything, because if you happen to have a number or you're leading off with a negative sign, you will need to distribute. So not a bad habit to have it grouped off. But this time, thankfully, not necessary. So you have 5x to the fourth plus 7 plus x to the fourth dy over dx plus 4x cubed y minus 3y squared dy over dx equals 0. Didn't accomplish a whole lot, but cleaned up just a little bit. Now remember, we need to sort. We need our dy over dx's on one side and our non-dy over dx's on the other side. So I'm just going to, and while I'm sorting, I'm going to factor. So I need this one and this one on this side. So I'm going to factor out the dy over dx while I do it. So x to the fourth, and then minus 3y squared. And then on the other side, the other terms need to go. And when they go, their sign will change. So negative 5x to the fourth minus 7 minus 4x cubed y. Okay, now I've got to divide through by x to the fourth minus 3y squared. Dividing through by x to the fourth minus 3y squared. Now, that is an abundance of negative signs. So technically, if you just want to have a more professional appearance, you need to reduce the amount of negatives you have. To do that, you could factor a negative out of the top. I will take this on test. That's okay. This would be, I'll take it. But just to make it look more professional, you do need to factor out that negative. And when you factor out that negative, what's neat is that the bottom is subtraction. Your denominator is. And you can take this negative that's right here, and you can factor a negative out of the bottom, and actually cancel them out. And what that does is it takes your denominator and it reverses it. So basically, your numerator is going to now be all positives, and your denominator just reverses, is the way that works. So if you really wanted to see it, you could look at it like that. Okay. So this would be okay. I will take it, but this will make me smile. Okay, just so you know. Okay, now I'm going to scoot down here. I'm going to copy 18 down below. So 18 is x squared plus y squared equals 25. Well, eventually it'll stop going. Well, whatever. x squared plus y squared equals 25. And we're just needing to solve for dy over dx. So 2x plus 2y dy over dx equals 0. And so let's see here, 2x needs to go over. So 2y dy over dx equals negative 2x. Divide through by 2y. Make sure you're reducing. When you do, your 2's cancel and you're left with negative x over y. And you are done. Okay. Let's see here. 19 gets a little bit more interesting because we throw in some trig functions. But don't fret, you can handle this. First term is just sine 2x. Well, you can do the derivative of sine. Derivative of sine is just cosine. Cosine the exact same angle. But since your angle's not x, you have to do the derivative of your angle, which happens to be 2. Now go to your next term. So your next term, you've got 3. And then the derivative of cosine happens to be negative sine. Well, we need to, let's see here, we need to take care of that negative. So we need to put a negative there. Sine, same angle, and then I have to do the derivative of the angle. Well, okay, derivative of the angle happens to be 4, but since it was a y, I've got to do dy over dx. Okay, and then equals 0 because the derivative of a constant is 0. Okay, try to clean it up. This is going to be 2 cosine 2x. Cleaning this side, this 4 and this 3 can come together and make a 12. Sine, oh, excuse me, pardon me, that dy over dx needs to come out with that as well. Dy over dx, it is not part of the angle at all. So it needs to go up there with the 12, even though it looks messy. 12 dy over dx, and then sine, and that's going to be 4y, because that's the only portion that is an angle. Okay, so we're trying to get the dy over dx alone. So this term needs to go over. Okay. And it doesn't really matter, quite honestly, when I look at it, the term that's negative would be the smarter one to move. So let's not move that one, let's move the one that's negative. So we've got 2 cosine 2x equals 12 dy over dx sine 4y. Now divide by the crap you don't want. You don't want the 12, and you don't want the sine 4y. So all that goes away. Do it again. Make it balanced. Okay, does anything reduce? Well, yes, it does. The 2 and 12 reduce. Do not touch those angles. They are trapped. You can't touch them, no matter how bad you want to. You can't touch those angles. They are trapped by the trig functions. Only thing that's free are those terms out, those numbers out front. Those coefficients are free. So you can make a 1/6, but you're left with that 2 there, and that'll be a 6 out front, and that 4 is right there. And they may make your fingers itch, but don't you dare touch them. Okay. And that's as good as that thing's going to get. All right, so find the slope of the graph of the function at the given value. So I'm hoping that y'all remember slope means derivative. So I need to find the derivative, and I need to plug in my x value. So let's do derivative of this. Looks like chain rule. Bring down my power. I've got my u value, power reduces by 1, and the derivative of the inside is 3. Clean it up, I need a 9. 3x minus 5 raised to the second. Okay, so time to evaluate. My given value was 5, so f prime evaluated at 5, so proper structure, please note this on your test. Plug in your 5. Okay, come over here, plug in your 5. Show me proper notation. And so that's going to be 15 minus 5 squared. And so you got 9, was this 10 squared, 9 times 100, and that would be 900. Okay, there you go. Got crazy big, but it was right. So, next one, you do need, whoops, excuse me. You got to know what it means. It says determine the points, if any, at which the graph of the function has a horizontal tangent. So you got to know what that means. So if you have a horizontal tangent, horizontal tangents have a slope of 0. that's what you're after, slope of 0. So slope, remember, is derivative. So your brain kind of has to do all this spider webbing. You got to put it all together. So your brain's thinking, okay, slope of 0, slope is derivative, so my derivative has got to equal 0. That's where we got to get. So when you read horizontal tangent, we got to end here. My derivative has got to be equal to 0. So I need to take the derivative. Okay, taking derivative. Looks like quotient rule. Okay, start with the denominator. Derivative of the numerator minus numerator times the derivative of the denominator over the denominator squared. Clean it up. 0 times anything is 0. There's nothing. And then 4 times 1 is just 4. So that's kind of strange, but that's okay. You can continue to clean it up, make it succinct. Okay, if this is my derivative, and I'm making my derivative equal to 0, that means, like for real, take this thing out and put a 0 there. And that's like 0 over 1. Remember what we talked about? Put it over 1 and you're cross multiplying. What happens to your denominator when you do that? Your denominator goes to 0 and you really only have the numerator. So this is really 0 equals negative 4. Can you solve for anything? Does that even make sense? This is nonsense. There's nothing to solve for. You have no values. So there's nothing here. So let's see here. So it says determine the points, if any, where it has a horizontal tangent. And so there are none. So there are no points. And I should have made a better sentence. I should have said, let's back up. Let's do a better job. There are no points where there are no points where there is a horizontal tangent. Okay, Lord forgive me. Okay, so now we're finding the second derivative. Okay, second derivative gets a lot more intense. We've got 2x plus 2y dy over dx equals 0. Remember, these are the ones where you have to substitute several times. So whenever you solve this out, you have the 2x goes over, he's negative, and when you divide it out, oh Lord, there's that wiggle in that board, you end up with a negative x over y, which is similar to what we had before. Okay, that you will have to use later. So when you come in and you do the second derivative, dx, like that, you've got to do quotient rule. Okay, so remember, it's the denominator times the derivative of the numerator minus numerator times the derivative of the denominator, which is dy over dx, and then the denominator squared. Okay, so clean it up. You have negative y. This right here gives me plus x. I need to substitute for this. That is this thing right here. So I'm going to put him in there. At this point, guys, we're just going to have to stop right there and pick it up in the next video. So we're going to pick it up right there and come back. Okay?